The scope of this video is to clarify everything you need to learn about dealing with nodes that communicate between each other thanks to the topic. And for doing that, this node contains publisher and subscriber. At the end of this video, you should have a good picture about topic communication in C++ and Python as well. If something will not be clear, don't hesitate to ask me a question in the comment down below and I will reach you out as soon as possible. If you haven't done it yet, don't forget to subscribe so you will benefit from a one-to-one discussion on the robotic application that you might have. Let's start this tutorial from where we have left in the last video, where we have written a subscriber node in Python and we made it subscribed to the topic message_topic. Since that we have covered this topic in C++ and Python as well, I think that it's gonna be a good practice to sum up everything you should have learned in just one picture. So here we go. On this screen you have everything you need to know for learning how to create a node with publisher and subscriber in C++ and Python. In fact, on the top left side we have a node written in Python that contains a publisher. On the top right side we have a node written in Python that contains a subscriber, while on the downside you find the same in C++. On the left the publisher and on the right the subscriber. You can point out that the publisher and the subscriber have the same structure, regardless if they are written in Python or C++. Let's analyze the publisher first. We can recognize these sections. First, the import of the library. Second, the main section where we are going to define the name of the nodes, the publisher object, and the rate function to set up the frequency of the while cycle that is coming afterwards. Then you have the while cycle, and in this while cycle there are the initialization of the MSG object, then you define what there is gonna be inside the object that you have created before, then you publish the message by using the publish function, and finally you sleep the node for the time that you have set before in the rate function. Bear in mind that most likely, if you have to deal with a publisher, you are gonna have a while loop, and you should control the frequency that you want to publish. The while cycle allows the publisher to publish a stream of messages continuously. We will see the importance of this frequency later on this video. But now let's see what there is inside the subscribers. Well, you need to import the libraries, then you'd better write the main function, where you initialize the node, giving it a name. Then if it's gonna be a C++ file, you need to initialize the node handle object. This is something that you have to do only in C++. Then you create the subscriber object where you have to indicate the name of the topic that the subscriber has to subscribe to, the type, and the callback function. The subscriber has constructed in such a way that takes as input a topic data and is going to elaborate it in the callback function. Finally, you need to write the callback function passing to it the message that you are getting from the publisher. Okay, fine. I hope that you have understood. I suggest you to take a picture of this screen, print it out and bring it with you when you write Node in ROS. This will be very helpful because it will give you a guide of how a node in general is structured whenever you code in Python or C++. Fine. Now let's close the node that are running and let's raise the bar a little bit. Now we are going to modify the node subscriber underscore pi node in such a way to do two things. First, to subscribe to a topic coming from the publisher Python node. Second, to publish to a message on the topic message underscore topic. This topic will be subscribed from the node subscriber in C++. This will be an example of three nodes that communicate between each other through topic. So let's do it. First, we are going to modify the name of the topic that the node publisher underscore pi will publish. And we're gonna call it message underscore topic underscore from underscore Python. So it's gonna be message topic from Python. This new topic will be published from the publisher node written in Python. Then the subscriber underscore pi node will subscribe to that topic. So we are going to update the sub-object modifying the name. I mean, modifying the name of the topic that is gonna to subscribe to. Then we are gonna create on this node a publisher object that is publishing on the topic message underscore topic, the same topic that we have been working on so far. Then we need to create the message to publish. So let's copy message is equal to string function because it's gonna be a string object. Then define the message to publish and let's write this is the second message. So we don't need to modify anything because the subscriber in C++ is already subscribing to the topic message underscore topic. And finally, publish the message. Here we go. Let's run and see what's going on. First, kill and run the ROS master again by typing ROS core on the terminal. Then you can run the Python publisher by typing, as always, ROS run, the name of the package that is gonna be node_practice, then the name of the executable file that in our case is gonna be publisher_py.py. Okay, it's running. Then, on the second hand, run the subscriber node written in Python that we have just modified. The one that has both subscriber and publisher object too. So type ROS run node practice and subscriber_py.py. And here we go, the node seems to work properly. It is subscribing to the topic message_topic_from_Python. The node is publishing a message on the topic message topic, but for now we are not able to see it. So if you want to check this out, we need to open another terminal and run the last subscriber node, the one written in C++. So type ROS run, the name of the package that is going to be node_practice, and the name of the executable file that is going to be subscriber. Here we see that the node is running and apparently, but only apparently, seems to work properly. Let's see if everything works fine by running the ROS graph. So open a new terminal and type ROS run, the name of the package that this time is gonna be rqt_graph, and the name of the executable file that is gonna be rqt_graph. And from the publisher subscriber architecture, we can see that the publisher_py node is publishing a message on the topic message topic from Python. This subscriber_py node is subscribing to that topic and at the same time is publishing another message on the topic message topic. And finally, the subscriber node written in C++ is subscribing to that topic. At the first glance, everything seems to work fine. But if you pay attention on what we have written in the subscriber C++ node, we don't see that this node is displaying on the terminal what we have asked to do in the callback function. So what happened? Well, it seems that the publisher put in the subscriber_py node is publishing too fast compared the speed of the subscriber node in C++ to run the callback function, and this is why we don't see the message displayed. So how to cope with this? Well, I have already told you that it is always a good practice to control the frequency on how a publisher is publishing a message. And to do that, we need to introduce a cycle while and control the frequency exploiting the rate function. So let's do that. So let's create a rate object at 10 Hz. Put the publishing section in the while cycle and control the iteration using the sleep method of the rate object. Okay, let's give it a try. Run the roast master first. Second, run the publisher node written in Python. Run the subscriber Python node, that this is the one that you have just modified, the one that is a subscriber and is publishing to the message topic. And finally, you can run the subscriber node written in C++. And let's discover together if now the node is able to process the callback function. Here we go, now it is working, and this time this node is displaying the message that the node in Python that we have just modified is publishing on the topic message_topic. And in fact, on this terminal, you can see that this node is displaying I heard, this is the second message, which is what we have asked to the Python subscriber node to do, or better, to publish. So let's run again the RQT graph and see what is gonna be now the publisher and subscriber architecture. And you can see that the application is running properly. In fact, we can see which is the node that is publishing on a certain topic and what is the node that is subscribing to those topics too. That's all for today. I hope this video could have cleared up any doubts you had in following the previous tutorials. If not, please subscribe to the channel to receive a one-to-one discussion on your robot application. And feel free to ask any question in the comment down below. I just want to thank you for staying with me until the end of this video. See you in the next video and keep learning robotics with Ross.